All right, guys, welcome back to lesson 11.6. See if I can get this up here just a little higher. Sorry, while I adjust. All right, I think that's good. Okay, so we're going to talk about pyramids today. All right, I'm sure you can visually imagine or think of what a pyramid would look like. If not, take a look at your notes because there's lots of examples of different pyramids. A pyramid will have one polygon as its base and then a bunch of triangular sides that meet at a point. Okay, and that's basically the definition. A polyhedron that has a base which can be any polygon and three or more triangular faces that meet at a point. All right, and we're also going to talk about solids. A composite solid is a solid that is composed or made up of two or more solids. Okay. So our formula for the volume of a pyramid that we're going to be using, the volume of a pyramid is equal to 1/3 times BH. Okay, B and H mean the exact same thing in this lesson as they did the last. B is area of the base. Remember, the base can be all different shapes. So if your base is a triangle, to find the area of a triangle, you use the formula 1/2 base times height. If the base is a four-sided figure, like a square or rectangle, you do length times width or base times height. If the base is a pentagon or a hexagon or an octagon, then you're most likely going to use the formula 1/2 AP, apothem times perimeter. So B, the formula you use for B changes based on the shape of the base. And then H, height, distance, how far apart are the two bases. Or, sorry, there's not two bases in these. Brain fart, there's only one base, so the distance from the center of the base up to the top point, that's your height, okay? All right, so the first figure is a triangular pyramid, and again, we name our pyramids based on the shape of its base. So see that triangle on the base, the yellow figure, that's your base. So if that's the base, it's a triangle, we call it a triangular pyramid. The next one would probably be, it's not a square, it's 11 by 7. So we call it a rectangular pyramid. Okay, the next one, 1, 2, 3, 4, 5, 5-sided base. So it is a pentagonal pyramid. Okay, that's how you name your pyramids. All right, so for the first pyramid, it has a triangular base. So for my base, which is a triangle, I'm going to find the area by using 1/2 base times height. All right, and then H, how tall is the pyramid? So let me put it back up so we can visually see it. Let's start with how tall is the pyramid. From the center of the triangular base up to the tippy top, we all see that segment that's 9 centimeters tall. That's your height. B, base, area of the base. Well, the base is a triangle. The yellow triangle has a base length of 6, and then that segment 4, that's showing how tall the triangle on the bottom is. So it is, hold on, I gotta yell at my dog. Chase, if he jumps on that mat, tell me please. Sorry. So the base is 6 and the height is 4. So it's going to be 1/2 times 6 times 4. All right, so 1/2 of 6 is 3. 3 times 4 is 12. Okay, so the area of the base is 12. The height is 9. So volume is equal to 1/3 times 12 times 9. 1/3 times 12 is 4. And then 4 times 9 is 36. And the units are centimeters cubed. Okay. So that's that first problem there. The second problem. The second problem has a rectangle as its base. So you're going to find the area of the base by just multiplying 11 times 7. And then the height of the pyramid is that a 15? Is 15. Okay. So the base is a rectangle. You find the area of the rectangle by multiplying 11 times 7. So that's for B. And then the height, make that nicer here. And then the height is 15. So it's 1/3 times 11.7. 11, sorry, that's 11 times 7. Can't even read my own handwriting. 11 times 7 times 15. And when you multiply it all together, you get 385 meters cubed. Okay. And for problem number 3, that was 2. For problem number 3, we're again going to use 1/3 area of the base times the height. What is the shape of the base this time? It's a pentagon, and the area is already given to you. The area of the base is given as 27, and the height is also given as 5. So you just have to fill that one in. That one's an easy one. 1/3 times 27 times 5. 1/3 times 27 is 9, and then 9 times 5 is 45 centimeters cubed. Okay. So that kind of gets us started. Let's flip to the back where we might need to draw our own diagrams to visualize what is being given. Okay. Is he talking to you? Sorry, my daughter is doing a gymnastics class again via Zoom, and there's another girl named Rylin, and I never know if my Riley is getting yelled at or the Rylin is getting yelled at. Wouldn't surprise me if it was my Riley, though. Get moving. All right. So, for problem number 4, it says a pyramid with a square base has a volume of 128 cubic inches and height of 6 inches. Find the side length of the square base. Okay, so there's some information given. We might want to draw a diagram to help us organize the information. So you're told that you have a square base pyramid. So I just would draw a square, put a little dot, connect the 4 corners, and there is my square pyramid. Okay? You don't have to be an artist. I am definitely not. All right, it says that the volume is 128 cubic inches. So then I'm also going to write down my volume formula, which is 1/3 BH, and then substitute in the given volume, 128 equals 1/3 BH. All right, what else is given? It says the height is 6, so I can fill that in as well. 128 equals 1/3 B times 6. Okay. You're asked to find the side length of the base. Okay. Well, I can solve for B. I could at least do that. So I have 128 equals 1/3 times 6 is 2. I have 2B. Divide both sides by 2. So I have 64 equals B. All right, what does B mean again? B is the area of the base. And what is this shape? We were told it's a square base. If it's a square and the area of the square is 64, what are both sides? If you're not sure, since it's a square, you can use the same variable like x and x. Right, and I know to find the area of that square, I do x times x equals 64. So that means x squared equals 64. Square root both sides, x has to equal 8. So I just found the answer. Each side of the base is 8 units long. 8 inches long, if we want to label with units. 8 inches long. Okay. Number 5. number 5, you're told that you have a pyramid with a rectangular base. So I'm going to draw a rectangle. Here's my rectangular base. Okay. It says there's a volume. It has a volume of 6 cubic feet. So again, I'm going to start with that volume formula, 1/3 pH. And it's 6 for the volume. All right, what else is given? The length of the rectangle base is 3 feet, and the width of the base is 1.5 feet. So 3 feet, 1.5 feet. So I know to find the area of the rectangle, I would do 3 times 1.5. So I can fill that in for B. 3 times 1.5. Okay. I can start cleaning things up and solve for H. And that's what you're asked to do, is find the base. Or, find the height. So, multiply 1/3 times 3. That gives you 1. So I have just 1.5 left. And then divide both sides by 1.5. Alright, so 6 divided by 1.5 will give you 4 as the height. So it's a lot of formula work, working with the formulas, working backwards through the formulas, finding your unknown, but also knowing what all the variables in the formula mean. Understanding that B, area of the base, that formula is going to change depending on the shape of the base. Okay, you have to be thoughtful about these problems. Number 6. I guess I should change that to a 6. Number 6. It says a pyramid with a triangular base. So I can start by drawing a triangle. Put a point. And then they all connect up there. It's terrible. I'm not 3-dimensionally drawing things. Okay, so you have a triangular base. There's a volume of 18 cubic inches. So volume equals 1/3 base times height, and it's 18 centimeters. I think I said inches before. All right. It says the height of the pyramid is 9. So the height of the pyramid is 9, right? This height right here from top, that's 9. So I can fill that in for H. Right? So before I read on, I can at least solve for B and then see what I need to do from there. 1/3 times 9 is 3, so I have 18 equals 3B. Divide both sides by 3, and you have 6 equals B. So I know the area of the base equals 6. Let me see what I'm asked to find. It says the height of the triangle base is 3 centimeters. Find the width. So basically they're saying this triangular base, if I just draw that triangular base, that triangle base has a height of 3. We want to know what is this width. Okay. They didn't call it the base of it because they didn't want to confuse you with the base of the whole figure. Okay, so that's why they called it the width. So I know to find the area of this triangle, I'm going to I'm going to call it the width. Okay, the width times the height divided by 2, or 1/2 base times height. And it's going to equal 6. So 6 is equal to 1/2 base times height. Where maybe I'll change this now to a B. Hopefully you're not confused by all the bases I'm talking about. So 6 equals 1/2 little b, and then the height of the base is 3. So I have 6 equals 3/2b. I have to multiply both sides by the reciprocal, so I'm going to multiply both sides by 2/3. That cancels over there. All right, so I'm going to have 12/3, which is 4. So the base of the triangle's base is 4, what are my units? Centimeters. Again, the math is not tricky. It's multiplication, division. The math is not tricky. but you do need to know what all the variables mean and understand how to plug in and work through these, organize your information, label correctly, and all of that fun stuff. All right, we're just about done. Okay, problem number 7. It says the pyramids are similar. So as soon as I hear similar, I'm thinking scale factor. Remember the last lesson, A to B is a scale factor. And then the ratio of areas is A squared to B squared. And the ratio of volumes is A cubed to B cubed. That should hopefully be going through your head. It says find the volume of pyramid B. So I'm going to write what I just said. Scale factor is A to B. Ratio of areas, A squared to B squared. And ratio of volumes is A cubed to B cubed. Okay? So they give you some dimensions to look at, right? And then they also give you the volume of the big one. You need to find the volume of the small one. So the linear dimensions, the height, that's going to help you with the scale factor. The ratio is 15 to 10. And then I can simplify. All right, so the scale factor, 15 to 10, simplify 3, right? 5 goes into there 3 times, 5 goes into there 2 times. That's your scale factor. Now, if I want to find the volume, I want to use the ratio of volume, or I want to use the ratio of volumes. So I'm going to take my scale factor and cube both of those values. 3 cubed to 2 cubed. Okay? So 3 cubed to 2 cubed is going to give you 27 to 8. This is the ratio that I'm going to use to solve a proportion. All right, 27 to 8, that's the ratio of volumes, is equal to the volume of the large over the volume of the small. The volume of the large is given. See under the diagram, volume equals 125. So the volume of the large is given. I'm trying to find the volume of the small. And just cross multiply and divide. Okay, so when you cross multiply and divide, you're going to get x is approximately, we will approximate this one, 37.037 repeating inches cubed. I could leave it like a fraction as well, but for this one, it would probably make more sense to put it in decimal form so we can compare to the 125 that was given. Okay. And last problem for our notes today. Okay. So the last problem, problem number 8, it says, the Pyramid Arena in Memphis, Tennessee is about 98 meters tall and has a square base with a side length of about 180 meters. A prism-shaped building has the same square base as the Pyramid Arena. What is the height of the building if it has the same volume as the Pyramid Arena? Okay, so the volume arena is equal to 180 times 180 times 98 times 1/3. Right? So that's going to be a huge volume of 1,058,400 meters cubed. All right. So you're going to set that equal to the other formula and solve for the volume, or solve for the height, excuse me. So 1,058,400 is equal to 180 times 180 times h times 1/3, because the height is what is different. So when you multiply and divide, you're going to get h is 98 meters. right, guys, that is it for lesson 11.6. So make sure you jump onto the online textbook to get your homework done, and I'll see you guys later. Bye.